Hello, welcome back to this series of tutorials on physics. My name is Dr. Garuma Abdisa, and in this part we will talk about the vector product, or which is also called the cross product of vectors. Let us begin our discussion by assuming two vectors making an angle theta with each other that are vector A and vector B. The magnitude of the cross product of the two vectors A cross B is equal to magnitude of A times magnitude of B times sine of the angle between the two vectors. And assume that these two vectors A and B have these components. And the cross product has the nature that if vector C is equal to A cross B, then this vector C is perpendicular to the plane containing both vector A and vector B. So these are the components of the two vectors A and B. So if vector C is equal to A cross B, then this C is perpendicular to the plane containing A and B. The consequence of this is that vector A dot with C is equal to 0 and vector B dot with C is equal to 0. The reason is vector C is making perpendicular angle to that of both A and B, so the dot product between each vector, that is A and B, together with C must be 0. So we can rewrite this one as A dot C is equal to 0 means, according to the formula that we have derived for the dot product of vectors, is AX CX plus AY CY plus AZ CZ must be is equal to 0. From B dot C is equal to 0, once again we can write BX CX plus BY CY plus BZ CZ is equal to 0. So if we solve these two equations simultaneously, that is these two equations, we can multiply this part by BZ and this part by AZ, so that these last two terms, AZ CZ and BZ CZ, will be eliminated and we will be left with only two equations with two unknowns, that is CX, CY are the two unknowns. And then we are going to eliminate CZ, because our intention is to find CX, CY and CZ, so that the vector C will be represented as a vector form of its components in the form of CX, CY and CZ. So in order to achieve that, after multiplying equation 1 and 2 with what is indicated there as the multipliers, in order to solve these problems simultaneously, after multiplication we will get these two equations once again, that is equation 3 and equation 4. And by subtracting this equation 4 from equation 3, we will get AX BZCX minus AZ BXCX plus AY BZCY minus of AZ BYCY is equal to 0. Because these CX here are common terms, here CY are common terms, so I have factored out the CX's and the CY's and I wrote it in this way. So this last equation can be written as PCX plus QCY, where my P is simply the term in the parenthesis here, and my Q is the term in this parenthesis there. So one possible solution of such equation is that CX can be Q and CY can be minus P. It has multiple solutions, and this is one possible solution of it. So if we do so, CX becomes simply Q, and my Q is this part, which is this. And my CY becomes minus of P, which is minus of this part. So I will subtract this one from this, that is to interchange the places. Then we get CY to be like this. By substituting this back into equation 1, that is equation 1 is this one. So here is my CX, here is CY. Substituting into equation 1, this is actually equation 1. Then now is the time to solve for CZ, because we already got CX and the CY. Everything is now known except the CZ. So by multiplying and eliminating similar terms, for example, these two terms are going to cancel each other out, then we are left with this last term. Then we will cancel the AZ from each term. Then CZ will be AX BY minus of AY BX. So this vector, which is perpendicular to the plane containing both vector A and the vector B, can be mathematically found out to be C is Cxi plus Cyj plus Czk, and we have mathematically found out the value for Cx, Cy, and Cz. So finally, C can be written in this way. So the cross product of two vectors A and B, which make an angle theta, the magnitude of the cross product of the two vectors is the magnitude of the product of the two vectors times sine of the angle between the two, and these are the components. So the cross product of the ijk unit vectors are also very important, so that we can summarize everything we have seen into a determinant of matrix, so that it will help us for easy remembering the formula. The matrix is not the proof, but it helps us to remember very easily. So the cyclic nature of these cross products help us to easily recognize the pattern, and it goes like this. If we write this cyclic ijk's, then I cross with j becomes k, j with k, j cross with k becomes I. If we follow the direction of the path, it will j cross with k will be I, k cross with I will be j. But if you reverse the direction, it becomes negative. That is, I cross with k is equal to minus j, j cross with I is equal to minus k, or k cross with j is equal to minus I. If you keep the path, it will be positive. If you reverse the path, it will be negative. This is a kind of quickly remembering how these cross products follow. So we often use the determinant form of a matrix to easily write the formula for a cross product for any given two vectors. I will show you that. But before that, what we do first is the direction of the cross product of any two vectors is determined using the right-hand rule. If we curl our fingers from A towards B, then A cross B is in the direction of our thumb, that is this finger. This formula shows us the magnitude, and the right-hand rule shows us the direction. Assume two vectors having these components, and C is their cross product. Then we write in matrix form. Actually, we will directly write from this determinant of a matrix what we have mathematically derived already. So in order to do that, what we have to first do is we eliminate the column and the row containing I, and we multiply these two remaining terms in order to get this term. We do the same for the j term. We cancel the column and the rows, and we multiply. For the j, what we have to keep in mind is always the matrix goes as this column is plus, this is minus, plus, and so on, if it goes on like that. So only for j, the direction of multiplication will reverse, that is az bx minus ax bz. That will give us this term. And for k, by cancelling the column and the row, ax by minus of ay bx, that will give us this term. So we wrote directly what we have mathematically derived already, which is vector c. And this is the matrix form of the determinant form of a matrix to help us easily remember this matrix multiplication. Let us see the proof of I cross with j is equal to k, because I showed you in a cyclic pattern. That is simply a matter of trying to remember it easily, but the actual proof is something which is coming from this matrix representation. So directly using the determinant form of a matrix, and by directly applying that rule, we find out that the cross product of I with j becomes k, and you can verify this very easily by yourself. Similarly, you can also prove the other identities. The other example is find the cross product of the following vectors. A is 2i plus 10j minus 6k, and b is 8i minus 8j plus 3k. So by directly following this determinant form of a matrix, we find that First we cancel the column and the row, and we multiply these two remaining numbers so that we get this part. Have a look at it by yourself. And also we cancel the column and the rows, and we multiply first this way and then we subtract this way for j because of the minus on top, and then we get this part. And for k, by cancelling the column and the row, we first multiply this way and then we subtract these two, and then we get this part. So if you reduce this, you will get c to be 24i minus 54j minus 82k. There are also different vector representations. Vectors can be represented with a letter and an arrow over it, or with boldface letters such as this boldface A and B. If a vector A is given by its components axi plus ayj plus azk, it can also be written as in the parentheses and the commas. You can write it this way, or with an angular bracket you can write it this way, or with this column matrix you can write it this way, or possibly with a column matrix and a parenthesis you can also possibly describe a vector in this way. All of them mean the same thing. For example, our ijk unit vectors can also be written as I is a column vector 1 0 0, j is a column vector 0 1 0, k is a column vector 0 0 1. Thank you very much, and this brings us to the end of this lesson. Never forget to hit the subscribe button.